Audio Jungle. Audio Jungle.
Optical Fiber Digital Line System. Chapter 3. 3.1 Wavelength Division Multiplexing WDM. 3.1.1 Define Wavelength Division Multiplexer WDM. 3.1.2 describes the concept of WDM. 3.1.3 Recognize the block diagram of WDM. 3.1.4 Identify the classification of WDM. Wavelength Division Multiplexer WDM. Wavelength Division Multiplexing WDM is a technology which multiplexes a number of optical carrier signals onto a single optical fiber by using different wavelengths. WDM is the optical counterpart of frequency division multiplexing. Separate signal modulate light source emitting a different wavelength. Each separate wavelength is an optical channel. Light from the separate sources is combined and transmitted through a single optical fiber. Then the wavelengths are separated again or demultiplexed at the other end. The concept of WDM. Multiple channels of information carried over the same fiber, each using an individual wavelength. It communicates with X and B with Y as if a dedicated fiber is used for each signal. Typically one channel utilizes 1320 nanometers and the other 1550 nanometers. Broad channel spacing, several hundred nanometer. Recently WDM has become known as coarse WDM or CWDM to distinguish it from DWDM. CWDM is an acronym for Coarse Wavelength Division Multiplexing, which is a variation of WDM, or Wavelength Division Multiplexing. It's an optical transmission system that is utilized for short distances, whereas Dense Wavelength Division Multiplexing (DWDM) is used for longer distances. How it works. CWDM offers 8 channels and 8 wavelengths, ranging from 1470 nanometers up to 1610 nanometers. There is a spacing of 20 nanometers between each channel. In other words, CWDM transmits fewer channels, by way of wider spacing set between each channel at distances that can reach up to 60 kilometers. The wider spacing, 20 nanometers as compared to 1.6 nanometers of DWDM, tolerates much high temperatures and much greater fluctuations in temperature than DWDM. Types of CWDM optical devices. There are 3 basic types of CWDM optical devices, which include 4, 8 and 16 channel MUX demo modules, or as an add-drop module. Distance of transmission. While DWDM multiplexing systems can transmit over longer distances because of the tightly packed wavelengths, CWDM systems are limited in their transmission capabilities. Typically, CWDM has the ability to transmit data up to a maximum of 100 miles. Benefits of CWDM. Coarse wavelength division multiplexing is a low-cost way to maximize the capacity of existing fiber optic cables by decreasing the channel spacing between wavelengths. It's much less expensive than DWDM, and a configuration isn't necessary. CWDM has the ability to boost the bandwidth of an existing fiber infrastructure, as well as ease the exhaustion of the fiber. DWDM. Dense Wavelength Division Multiplexing DWDM is wavelength division multiplexing WDM with typical channel spacing of 100 GHz for 40 channels and 50 GHz for 80 channels. Each channel contains a TDM time division multiplexed signal, and each of up to 80 channels can carry 2.5 gigabits per second for a total of 200 billion bits per second by the optical fiber. These signals use the third transmission window called the C-band, meaning the light beam wavelengths are between 1530 nanometers to 1565 nanometers.